So here we go. We are live on LinkedIn for the next 30 minutes. Thank you so much for joining this IONOS Tech Talk today. Of course, you're very welcome to send questions while we want to explore what unites the largest hosting company in Europe, IONOS, with the Haas F1 team. Well, a few weeks ago at our talk with Günther Steiner, team manager of the Haas F1 team, we came to the agreement some of the main topics are reliability, safety, strong performance, and of course, a strong team. And I'm pretty sure today's guest will agree to these main topics. He was able to turn his passion for motorsports into a career in IT at international level, including some of the biggest names in the industry from Honda to Mercedes-Benz. Welcome to CIO of Haas F1. Welcome, Gary Foote.
Thank you very much, Claudia, and thank you for having me. And also welcome to all our guests that are listening live on LinkedIn.
Thank you so much to make time for us today. So where are you joining us from?
So I'm actually in our UK operations centre, which is in Banbury, just outside of Oxford.
And be honest, can you still count all the virtual talks and presentations you gave over the last month?
Probably not. No, probably not. But that's a good thing. You know, it's nice to be able to communicate with, with business people and fans alike. You know, Formula One attracts a huge audience, so it's a great way of connecting back.
Yeah, it is, of course. And well, though we would love to meet in person soon, we're gonna now enjoy your talk, your presentation on the key topic of data being the key for success now for IONOS and also for Haas F1. We are very much looking forward to your presentation. The virtual stage is yours, Gary.
Thank you very much. Right, well, welcome everybody again, and thanks for the great introduction as well. Great to be here on LinkedIn Live. As Claudia mentioned, my name's Gary Foote. I'm Chief Information Officer at Haas F1 team. I'm responsible for the technology and IT functions here. As Claudia mentioned, I've been in Formula One must be 15 years or so, and I've actually been with Haas since the team started in March 2016. And as the title slide suggests, I'm here to talk to you a bit of an overview on data and technology in motorsport, how that specifically relates to Haas, and how we work with our partners and suppliers such as IONOS. So before I get too much into the technology, I wanted to give everybody a bit of an overview on the team, a little different from some of the other teams up and down the pit lane, and a bit of background. Haas F1 was actually conceived in middle of 2014 when Gene Haas, the team's owner, secured a spot on the Formula One grid as a new entrant rather than through the purchase or acquisition of an existing team, which was the first time it had been done in quite a while. Gene himself, sort of a self-made man whose primary responsibility is Haas Automation, who's our title sponsor. And he started that in 1983 and has built that up to be one of the largest machine tool manufacturers in the world by volume. A huge racing fan. I believe the story goes that Gene tried to do a bit of racing himself back in the day and realized it's actually quite tough and that team ownership might be a better route in. So he started a NASCAR stock racing team, which he quickly formed a joint alliance with the NASCAR champion at the time, Tony Stewart, to form Stewart Haas Racing. A hugely successful team. They took the Cup Series championship in their third year, I believe, and actually won the regular season championship just last year in 2020. And then obviously in 2014, he secured the entry for Haas F1, and we fielded our first two cars in Australia in March 2016. Important also to talk about is the concept behind Haas F1, and again, how we differ quite dramatically from the other teams. And it's important to put this foundation down because it does sort of feed into the technical strategy and the technical stack, which I'll sort of come on to a little later on. The team was born out of the idea of an element of the rules that talks about listed parts. And a listed parts is a section of the rules that lists out all the bits of a car that a team is required to design and manufacture themselves in order to be able to call themselves a constructor. It's sort of big list of bits, but primarily, and I'm generalizing here, sort of the wet surfaces and the aero surfaces on the car, the things that make your car unique from all the others. But by definition, if there's a listed parts list, there's now this sort of other list, which we call the non-listed parts, which doesn't exist in written form, but is effectively a subtraction of all the parts that are left that you're not required to produce yourself. And the concept of the team was born out of the fact, well, let's just make what we have to, and then let's go out to market and find experts and technical alliances that allow us to bring in those additional parts. And what that results in is a very small team and a very agile team, but still a team that's able to compete on the stage, with much larger teams. Those partnerships were born. The very well documented one is with our partner and supplier Ferrari. We do procure an awful lot of the parts that we're allowed to from Ferrari, but there's also a large number of other trusted partners and suppliers behind the scenes. Dallara, we have an alliance with, where they do an awful lot of our manufacturing. And then also in my world, I have a huge number of very trusted suppliers, such as IONOS, who provide technical expertise into us so that we don't have to do that ourselves. It's a very disruptive and visionary way of running a team, challenged at the start in its inception. But actually, I think more and more teams are starting to look at this model and start to realize, especially with the budget cap that's coming in, how they can drive efficiency into their teams. But I know everybody wants to hear about technology, so I'm going to give you a sort of an overview of technology in Formula One. And what you really see when you come to a Formula One team, and those of you that have been in them or maybe even work for them, is fundamentally not that different from what you would see in any other advanced manufacturing-led, technology-led organization. I've got some stats on the screen here of our particular environment, which is probably much smaller than some of the other teams, but really, a lot of your businesses will be employing the same techniques here. We've got, a bunch of physical servers. We use virtualization very heavily here, sort of 250 probably virtual machines across our estate, over a petabyte of storage. We're a heavy Windows environment, very embedded in Office 365. We do run Linux systems, where the application requires it. Our particular company has a few challenges with our multi-continent setup. We have our head office is actually based in Charlotte in North Carolina, where the NASCAR team is based. We've got the operations center that I'm based out of in Banbury in the UK. And then we have two sort of technical excellence centers out in Italy. But ultimately, we do have an awful lot of enterprise grade, but still largely commodity equipment. We obviously do have some more specialist and custom pieces in there. The picture I've got on the bottom of that screen there is our high performance compute cluster, which we purchased in 2018, which is a multi-million-pound investment, and sort of gives you an idea of some of the more specialist equipment that we would typically employ. This particular example is primarily for doing our computational fluid dynamics, which is where we simulate airflow over the car. A huge sort of mathematically heavy application, and it required that investment. And then we have a lot of specialist software. Again, following our business model, we tend to procure as much of that software in from sort of specialist parties rather than fill the seats with software developers. I could talk about data in Formula One, for hours on end, and again, as a regular business, we have our IP data, and then we have business data, and I'm pretty sure the viewers don't really want to hear about business data with finance and human resources. So I've kind of honed in on car data, which I think is, what the viewers and the fans and everybody watching can resonate with. So this is our typical data flow, which I'll talk you through. And we're going to start up there on the left-hand side there with that little race car. So the data that's coming off the car drives our business significantly, and it all stems from sensor data. So this is physical and mathematical sensors that are covering the car, and they are reading data points. Now, those data points can be at low frequencies, like even as low as 1 hertz or less, so just one little data point a second. But we even have some sensors running up to 100,000 hertz. So that is, a multitude of data. And different sensors perform different jobs, maybe pressure sensors, temperature sensors, stress sensors, that sort of thing. They're all feeding back onto an ECU or an intelligence system on the car. And that car is going to do two things with that data. First of all, there's a subset of the data which is transmitted live over the radio, over our telemetry system. And we're limited by the bandwidth there. And so the bandwidth is carved up in such a way that the data that we need to be able to make real-time decisions as the car's going around is transmitted over telemetry into our garage at the circuit. It's collected by the systems that my team look after and is brought, and quite a lot of mathematics is performed on that in real time. And then that data spans out to various engineers who are performing functions in real time. Claudia alluded to actually our safety, reliability, performance, and efficiency acronym. This is essentially how we carve up data. As the name suggests, safety is number one. A lot of people will gravitate towards safety of the driver, and that is hugely important. We all saw the issues, with Roman last year, and how safety in Formula One has made such huge leaps in the last few years. But the safety comes out to, maybe the people that are working on the car. There's incredibly complex and high voltage electronic systems, for instance. We need to understand that car is safe when people are working on it. Maybe even so far as the marshals that are on the circuit, the fans and spectators who come to see the sport. Safety is paramount important. And we have people who are dedicated to looking at the data coming live off the car to make sure everything's safe. Reliability is obviously important, arguably more important than performance. You can have the quickest car in the world, but if it breaks down, that's not much use to anybody. So we do put a lot of emphasis on reliability. So we'll have dedicated engineers at the circuit that are looking at all these sensors to understand the reliability of the car. Are they seeing temperatures starting to build up? Are they seeing pressures starting to build or fall? And they'll be able to make key decisions that will affect the outcome of the race. Maybe they see something that's going to start, is under a particular amount of stress, and they can adjust or advise the driver to a different way of driving in order to reduce that level of stress. That all comes from that live data. But there's also a secondary subset of data that comes off, and that is the offload. This is where the rest, I think is probably the best way of putting it, the rest of the data is stored. And you'll see sometimes on the TV, and sort of challenge you to have a look in Abu Dhabi this weekend, you'll see quite often a cord being plugged into the car. We call it the umbilical, and it is literally an Ethernet connection straight into the ECU, and we pull that data off. And that is a sort of a post-run analysis, and that's all the data that continues, that has more fringe benefits. We do still have safety, reliability, but it's more performance and efficiency based. I am generalizing quite heavily here if there's any race engineers watching. And the performance data is, we want to look at how quick was the car? How can we turn that into a quicker car, maybe for the next run, maybe for the next day, or even maybe for the next event. And then data for efficiency. Efficiency is a rather wide scoping word, so it's almost a bit of a catch-all. But what we're looking there is, are we making the best of the tools we have? Is that human tools? Is that fiscal tools? Is that physical tools? Are we making the best use of it? And our data helps us do that. But furthermore, that's all local to the circuit. What we then do is we push that live and the offloaded data streams out over our MPLS network, which is spun up at every event for us, and out to our factories in the UK, US, and Italy. I note now I don't have an Italian flag on my graphic there, so I'll get that updated. But it does go to all three locations. And again, we have subsets of engineers in those locations who are looking at that data in real time and feeding that back over our radio system, back to the engineers at the circuit. And that serves two purposes, really. On the one hand, we can only take a certain number of people to the track. It's an operational limit that's placed on by the sport. And so, we're very careful about who we place at the circuit to make sure that they're providing the maximum value they can. But outside of that environment, in the UK, the US, and Italy, we can fill that up with more people. It's also a great cost-saving measure. The less people that we're sending to the circuit, the less cost we're incurring, and also a safety consideration. The less people that we're traveling all around the world, the better. And that live data is around a second, or less before that data will be in front of eyes from the car to people in the UK, Italy, and the US. It's quite interesting because if we're then watching the TV feed in the UK operations room, we'll often see on data the race start quite a few seconds before we'll see the cars pull out on the grid. So you have a situation where you're looking at the cars stand still on the grid, but you kind of know what's happening at the first corner. I wanted to touch on the cloud as well, and how it suits Formula One as an industry. Cloud has been around quite a while now, but the mainstream adoption is now in every business. Every CEO and every CFO is now considering cloud, and conversations are now happening at the executive level on how cloud can benefit and how it can add value to organizations. And Formula One is absolutely no different. In fact, it suits Formula One particularly well with my really quite crude graphic I've got up there of race weekend and peak load. And something I'll talk a little bit further down is, we have these 22 events, 23 races next year, in fact, where, demand for technical processing or technical ability goes up and then comes down. And, cloud is built around that scale up, scale down model. But more importantly for Haas, it suits our business really quite well. As I talked about at the start, our business model is very outsource heavy. The last thing I can ask for with regards to resource is a head to add to my team. I need to have exhausted other opportunities, and the cloud gives me that model, that platform as a service, software as a service, even infrastructure as a service. By taking that off-prem, I remove the requirement to have all the fringe services that support that environment if I was to bring it in-house. Don't get me wrong, on-prem is still required. Most businesses would agree that a subset of infrastructure is required on-prem, especially in Formula One. We have high data volumes. And so a big consideration when we're looking at our own cloud adoption is data volume in and out of the cloud. But something that often gets asked to me is, am I in Haas or are we in Formula One, cloud first? A term that gets bounced around in an awful lot of forums these days. And I would say, no, we're not cloud first, because I feel that cloud first clouds judgment, excuse the pun. But I do see us as cloud forward. What I mean by that is, we will look at a given requirement or a service or a platform, and we will understand what are the pros and cons of having that on-premise versus having it in the cloud. And we talk about an awful lot of numbers, a lot about efficiency. We talk a lot about data volumes, and we talk a lot about redundancy. And at the end of that process, if the cloud makes sense or we're on a borderline, we'll always tend to gravitate towards it for the reasons I mentioned earlier. I wanted to give everybody a bit of an overview on how we do actually use the cloud in Haas, and specifically how IONOS are helping us on our cloud journey. And I thought a really interesting model would be to talk about FEA, which is finite element analysis. So FEA is effectively sort of a computer-based numerical technique which calculates behavior of structures, strength of structures, deflection, stress, flexibility of materials. And it's very mathematically heavy. And if you imagine our car as a sort of covered in carbon, we have an awful lot of different materials, and they do an awful lot of different jobs. There'll be brittle but strong materials. There'll be flexible and forgiving materials, depending on aero loads or physical loads that are placed on the car at a given time. Lots of things in the media about sort of flexible carbon on wings. It is a great example of where, there are certain parts of a car that are designed to move, and there are certain cars, parts, the chassis, for instance, which are designed to be, rigid and much stronger. And what I've tried to demonstrate here on this slide is how we split the typical workload up. On a small workload for FEA, a user or an engineer would typically do it on their local machine. And the reason they do that is super small, many iteration calculations. So they just need to get an information really quickly. They've got their prep, they want to put it into the calculation and get their results out in real record time. And it suits that really small workload. Those of you who are watching who are familiar with FEA will know that it's incredibly computationally heavy. And so really running it on laptops, even the sort of fairly beefy ones that will buy those engineers, is not great. Besides, it usually means that laptop's then tied up. But it is available as a mechanism. Medium workloads, this is where we would typically give a more high-powered workstation and that could sit under a user's desk, or it might sit in a data center. But fundamentally, it's detached from their main working environment. So they're able to take a piece of workload, send it down to the workstation, leave it crunching while they do something else, and then get those results back. But the challenge you have is when you want to scale up that medium workload, I can add 2 workstations or 5 workstations or 10 workstations. And then all of a sudden, they really do need to go in the comms room. Once they're in the comms room, I've got to cool them. I've got to power them. I've got to have engineers to fix them. I've got to depreciate the asset. All of these sort of business challenges start to become a problem. That is where the cloud is such an enabler for our business. In this particular case, what I can do is I can provide a function within IONOS's cloud to the engineers for them to be able to scale up that compute at their disposal. So, that can be a small scale up, and they don't mind leaving it so long, or it might be a big piece of calculation that they want to do very rapidly, and they can scale that up as much as they need to, far more than I would be able to do with on-premise infrastructure. And it's that, sort of outsource model, and almost, to coin a phrase, a bit of a hybrid approach that works really well for our business. We're able to take care of small workloads and rapid workloads locally, but bleed out our fringe services out into the cloud, meaning that I don't have to scale that up in my own data center, usually to the peak point. Another similar example I have here is simulation and lap simulation. What we have here is the software group will maintain a mathematical model of the car, is maybe the best way of putting it. And that model of the car is used to run through a huge amount of simulations and checks that ultimately will help set up the physical car. It's going to give them a bunch of data that allows them to tune the suspension and the steering and the brakes on the car for a given race weekend or a given event. We're talking about that scale up and scale down model that suits the cloud so well. So, when they're trying to do that for a race weekend, they get everything prepared. They'll send it out into those worker processes, into the cloud. They'll churn it all around. They'll get the results back. They'll make a change. In it goes again. And you have that cycle of iterative change, almost sort of a DevOps style model that allows you to formulate the setup of the car, and thus you get a final set of numbers. But then you're done. And that huge computational load that you've spun up on those worker processes, you can spin them back down. You're stopping incurring cost, and you're stopping incurring, the upkeep of that infrastructure. If we were to do that on-prem, for the reasons I mentioned, I've got to scale up to the point where all the worker processes that are required for that process are available to that group, and thus I can, from a cost perspective, I can either set that at a certain point, and that's the infrastructure I maintain, or, the bigger I get, the more cost I incur. They're just 2 examples. There are many, many more that we're doing in the cloud. As I say, we do have a fairly heavy cloud program, but one area that we want to look at in the future, I often get asked, and that is high performance compute. Now, high performance compute in the cloud is not a new thing, especially in a private cloud. There are plenty of providers that will come along and they will sell you a cloud hosted HPC. That's nothing new there, but that's really an OpEx versus CapEx model as much as anything. What you're doing is you're turning capital purchase and on-prem into a sort of platform as a service rental model. But what we want to do with the help of IONOS's expertise is to put that into a more public cloud, that scale up and scale down ability, but through huge parallelization. And one of the reasons we want to do that is for our computational fluid dynamics program. Now, I mentioned earlier on that sort of huge Cray, now HPE, I should say, supercomputer that we put in was a multi-million-dollar investment put in 2018. It's still got some life, but at some point in time, it's going to be inefficient for the job it's doing. And at that point in time, I'm going to have to be the one that phones Gene and phones Gunther and says, hey, can I have a bunch of $1 million for another one of those computers? And that model is what we want to shift away from. What I'd much prefer to be able to do is to say, I don't need to buy another big capital purchase like that. Instead, what I can do is put this into the cloud. And importantly, HPC workload and CFD in particular is a bit of a sine wave. And so the cluster that we've bought on premise is scaled up to the peak of those loads, but regularly it's running at 50, 20, even 10% sometimes. And that's because we're balancing, work that's coming into the CFD process, maybe perhaps to work that we're doing in our wind tunnel. The background there is that the sport governs the amount of tunnel time and CFD compute that we can do. There's a sort of a complex algorithm that a token system, for want of a better word, where you get a certain number of tokens in a certain period, and you can spend them. You could do more CFD or you could do more tunnel time. That mechanism means that sometimes that cluster isn't really working particularly hard, and that's where a cloud model will work so well. There are regulatory challenges. Again, I mentioned the sport does govern what we can and can't do, specifically with regards to CFD. And it will be our challenge to work out how we can match those regulatory requirements, working with the sport. But this I see the future of CFD, and certainly HPC is an area that you'll start seeing. Some of your own businesses maybe even using it. A friend of mine that works for a games house, is a games publisher. They're using HPC to start simulating game testing and gaming engines. So this is an area that's really up and coming, and we want to be on that curve where we can. And that is a very whirlwind tour of tech in F1. I'm conscious I've kind of skimmed the surface, and I think I've seen lots of questions popping up in the window just behind there. So Claudia, I'm assuming we've got some time to take some questions. Is that okay?
Yes, we do have some time, and as you just mentioned, it's just the surface. I'm just sitting here like, man, you're the guy being responsible for all the technology that could stop the car on track, right? Or could the car actually run without all this technology and data?
Not quite, actually. Yeah, the technology is required to run the car. The car is fundamentally, it comes back to safety as much as anything. That data tells us that the car is safe. If we are unsure of that, or if the data is unavailable, certainly for more than a few seconds, then as a general rule, we'll choose to bring the car in, or worst case, retire the car. So technology completely underpins it. Am I responsible for it? I am, but I try not to think about that too much at race weekends.
I get that. Okay. Well, we have some questions popping up here. Like, aside from the cloud, what cutting edge technologies are you also concentrating on? Is there also a look at quantum computing, for example?
Yeah, it's a good question. We're looking at I think part of Formula One's attractiveness, actually, it's certainly why me and a lot of my team, love the sport, is that we want to stay ahead of the technical curve. And so we talk about how up and coming technologies can help us. AI and machine learning is something that's been around a little while, but Formula One's been a little slow to adopt this in areas. But it is an area that can really help. Even if I take just that example of the number of people we can take to the circuit is limited. I've got a pool of girls and guys that have unbelievably mathematical minds. If I can have automation or machine learning take on some of the, I don't want to say mundane work, but the more the repetitive work that they're doing, that's going to free them up to do something that maybe AI can't function at the moment. So, AI is a great technology. We're using it in a number of areas already, but I think there's so much more scope. Trying to think what else. Wearables is another good one. Human performance is something that I think the sport has really transformed in 5 years. I would say 5 years ago, it was, every team member added huge value to the team through their minds, of course. But what we're doing is we're taking that to another level in human performance. So understanding how are humans going through what they go through at a given point in a race week, and how we can, maximize their performance.
Well, let's see what else we have now. It's just getting more and more. I don't know where to start. There are also
already my window. Here it is.
Internships. So maybe we can leave some details after So very inspiring talk. Everybody is very happy. You already mentioned that the circuit side and factory side, they receive the same data, right?
That's right. Yes. So we take, as I say, there's two data streams. There's the live stream, which is a sort of subset of the data that's transmitted back to the factory. And we will have engineers concentrating on strategy, on performance, even IT. We have some IT engineers that are taking some of that data and using it to make intelligent decisions. We have a very advanced radio system, a sort of constant two-way communications matrix that we will then be able to use staff to talk, on a one-to-one basis straight to the pit wall, for instance, or even on a one-to-many. So somebody will be able to read a piece of data in real time and say, hey, here's what I think you guys and girls should be doing. So it allows us to kind of bleed out from the circuit. It's important to note that we design the track very much to be able to function independently. As a technology stack, we're very reliant on the communication lines in and out, and we need to make sure that if there's an issue with that we are, we can still, run the car, but we run it with a big Achilles heel if that happens, because they do add so much value, the people offsite.
And you just mentioned you send the data real time, but so do you send all the data or you extract?
No, we extract certain amounts that need to be transmitted live. So there'll be certain amounts, there'll be certain data that is used for real time, and certain data that really has limited value in real time. That data is put onto an offload, and that's transmitted sort of after the event. Still pretty quickly though. I mean, I don't want to quote numbers in case I get them wrong, but we'll typically have an offloaded data within sort of 10 or 15 minutes into the UK for post-run analysis. And we have lots of tools that will run an awful lot of processing on that data.
Okay, we are almost running out of time. I would love to take one more question about budget. Does performance on track affect budgets that departments get given? And if so, how sustainable would it be given the last few seasons' results?
So budget's taken a bit of a kind of slide. I mean, F1's always been a huge budget sport, which is partly why it makes it so great. But one of the challenges that we had is that, from a competition perspective, you had quite a broad range of budgets. And so what the sport has introduced is a budget cap. Mm-hmm. And it's an operational budget cap. And what that does is it's squishing the teams together. And, everybody's seeing this already. I mean, what a great season this season's turning out to be, to have the two lead drivers on the final race tied on points, that's sort of textbook stuff. It's really great. And so the initiatives that Formula One have come up with, they're working for sure. How it affects us specifically, what it does from a technology perspective is it tailors your efficiency. Everything that you do, you have to have much more of an efficiency hat on. You have to understand, for every, in a sort of almost a rudimentary way, for every pound I spend or dollar I spend, that's a dollar I'm taking away from the car or its development or its performance. And so, I'm very lucky at Haas that we have, the technology function we were able to provide a lot of value. And so, from a budget perspective, I get the tools and resources I need to do the job. But I do need to consider that every purchase or every initiative that I come out with does affect money that can be spent in another area.
Well, Gary, thank you so much for all these great insights. I have to let you go already. I'm so sorry for that.
No, don't worry. Well, thank you for having me. It's been really enjoyable.
Great talking to you. Thank you so much. Please stay healthy and see you soon again, okay?
I appreciate it. Thanks. And thanks for everybody for tuning in.
Yes, everybody out there at LinkedIn following us, thank you so much for joining. Next year, we will be back with IONOS Tech Talks, of course. Meanwhile, why not listening to our brand new podcast, Drive Digital Success, launching on Friday, 7:30 a.m. CET, where you get a lot of more insights even Formula One fans can rarely get. So don't miss out on that. For now, thank you so much for joining. Stay healthy, take care, and bye-bye.